Okay, here we are going to simplify some algebraic fractions. Simplify usually means write it in such a way that you can cancel common factors in the numerator and the denominator, and then once you've done that you can rewrite it and it looks a lot simpler because there's smaller numbers or you've reduced powers or there's less terms or something like that. So the first one we're going to do is 10a squared b, 10a squared b over 2ab cubed. Okay, so looking at that, now you might not need to do this. I'm going to do it because I'm explaining. I'm just going to completely split this into factors. Now the first thing to notice, you've only got two terms. You've got something on the top and something on the bottom. When I say terms, basically terms are separated by plus signs or minus signs. If you don't have anything like that, then this thing's split into only two terms. So basically, if I can cancel common factors straight away. Now, if you're very good at this, you don't need to do this next step. I'm doing it more to demonstrate it in a teaching, from a teaching point of view. So I'm going to say this equals the 10. I'm going to split that into 2 times 5 times a squared. I'm going to call that a times a, and b is just b, so times b. All of these things are being multiplied together over, I've got 2 times a times b times b times b. So once you've got it like that, you can cancel common factors. So I can cancel a 2 with a 2. And technically, you're really dividing top and bottom by 2, so you could say that's 1, 1. I can take this a with this a and call that 1, 1. I don't have any more a's in the denominator, so I'm finished with a's. So now I can take a b with a b, 1, 1. So now I am left with, on the top, 1 times 5 times 1 times a times 1 is 5a. Over on the bottom I have 1 times 1 times 1 times b times b. So it's just b times b, which is b squared. So you can see I've reduced the numbers. When I say simplify, we've turned the 10 and a 2 into a 5, and we can only see the letter a once. It was written twice before, and the same with b. So it could definitely be argued that that looks a lot simpler. Okay, a second one, 6x minus 12 over 36. Now this is different because, I'll just put some dots there. This is different because we now actually have 3 terms. Remember I said terms are separated by plus signs or minus signs. So on the top you've got 6x, that's one term, minus 12 is another term, or you could say, well, it's subtracting 12. But either way, you've got 1, 2, 3 terms. So to do any cancelling, there's a shortcut. If you're very good at it, you can say, well, look, I need any common factor to be a factor of all 3 terms. So if you're very good at this, you can say, well, 6 goes into all of those. Just divide everything through by 6. But actually, it's better, it demonstrates more understanding, and I think you're less likely to make a mistake if you factorize the numerator. In this case, it could be the denominator in some cases, or in a lot of cases you need to factorize both. So I'm going to rewrite this having factorized the numerator. So I can see the 6x and the 12, the highest common factor of those is 6. So that equals 6x minus 2 over 36. And I suppose I could have written the 36 as 6 times 6, but I'm hoping that I won't have to do that. Now, because this numerator is factorized, you can think of this as kind of one whole thing. So this is 6 times by the x minus 2. So now I've really just got 2 things. Okay? So I can say, well, 6 over 36, I can divide both of those through by 6. So that is going to be 1 and 6. So now you end up with x minus 2 over 6. Okay, and actually that is finished. You will see a lot of people, please don't be one of them, that will look at the 2 and look at the 6 and say, oh, I can divide both of those by 2. You can't do that because you have 3 terms, x minus 2 and 6. Minus 2, also 2, is only a factor of these 2. It is not a factor of the x as well, so you are finished. Okay, a third one, we have 4x plus 20x squared over 12x. So you look at that, again, you've got 1, 2, 3 terms. So any any cancelling, you need to think about common factors of all three terms. So I suppose if you were really, really good at this, you could say, well, 4 goes into all of those, and so does x. So you could divide all of these terms through by 4x. I'm not going to do that. I'm going to do it exactly the same as we did over here. We're going to factorise the numerator. So the highest common factor of the numerator is 4x. You can see x goes into there, and x goes into there, and 4 5s are 20. So I'm going to pull a 4x out. 4x times 1 equals 4x, and 4x times plus 5x equals plus 20x squared. We've still got 12x on the bottom. And now, if you can just see that, you can probably just say, well, 4x over 12x. If you wanted to, you could write this as kind of 4 times x times 1 plus 5x. It might help for understanding. You really shouldn't need it. And I could write the 12x maybe as 4 times 3 times x. And now you can see I've got this lovely factorised form on the top, everything being multiplied together. That's when I'm in a position to cancel common factors. You can't do it before that. So 4 over 4, 1 over 1, just divide through by 4. X over x, 1 over 1, divide through by x. There's no more common factors left. So the answer is, all you've got left on the top is 1 times 1 times 1 plus 5x. So that's 1 plus 5x. We no longer need the bracket. Over, on the bottom, 1 times 3 times 1, well, that's just 3. And this one doesn't sort of tempt you into trying to cancel it anymore, because you don't have any common factors that are obvious even between just two terms. So it's definitely finished.